Okay, we are now at Galveston State Park. We're going to make 2 stops here to see the entire profile of the barrier island. The barrier island here on one side has the Gulf of Mexico, out here, the ocean, and on the back side is Galveston Bay. We'll do a second stop to see some of the features of what we call the Back Bay area. But right now we're going to look at some of the oceanside features. Obviously we have a beach. This beach, as you can see, people go out for a long distance. It has a very shallow profile because we're on the edge of the continent, and we're not in the deep water where we have oceanic crust. So we have a very shallow profile here. You can see people walking out tens of feet and they're still only at waist deep water. Other places you go to beaches, they have a very different profile where it drops off very rapidly, but here along this barrier island where we're really on the edge of the continent, we have this shallow profile. And because you can see waves out there for a long distance, and you can see the whitecaps, the waves breaking out there. Waves action is such that it breaks when it's at a certain depth, and it has to be pretty shallow, so that you can tell, because the waves are breaking way out there, that this is shallow for a long distance. So we have the beach and the deposition, and then we come up the beach and we get the tidal zone. Right now we're at high tide, so we cannot see the tidal zone, and so we're at high tide. You can see the water is just coming up to the highest point it will reach on the beach, and then the tide decreases and goes down. And then we come up the beach and we get what are called coppice mounds, which are these small areas of grass and sediment where there are just a couple of isolated grasses. And if you look right near where the trash can is, there's a bunch of plants, and you will notice that the sand is piled up at this mound, and that's because the plant traps the sand, and then the vegetation grows, gets more sand. Behind the coppice mounds you then get the dunes. Here the dunes are very shallow out here, very small. They're from the wind blowing sand up the beach, and then you get into more dunes that are higher back through the area we walked in. When you were walking through, you probably didn't notice them, but we walked through a cut, and then you can see right now the topography of the dunes where they go up and down. I want you to look at the sand in the dunes and see how it compares to what you've seen on the Brazos River and elsewhere on this field trip. I like to look at it with my hand lens so that I can see what the minerals are. And now this sand, if you look at it, is almost pure quartz. On the Brazos River, it had a lot of clays and other parts, and where we were at Old Brazos, it had a lot of shell fragments, but the sand in the dunes here is almost pure quartz. But what is the grain size of this? And so I asked you to feel it. Do you feel the individual grains in your fingertips? And you can, but you can't really see them. So this is a very fine grained sand. And as you can see, it blows away very easily. Okay, sometimes you can let nature do work for you. In this case, this is where a crab has dug a hole. And the crab has kindly dug out for us some of the underlying sediment. If you pick it up, you will see that it sticks together. I know it's a little bit wet, but it's sticking together partly because there's a large amount of clay in there. If you look out at the water, is the water blue? No, it's not blue. And that's because there's a lot of suspended clay in the Gulf waters here, because we have the water, the longshore current is bringing the water from the Mississippi. And the sands get deposited in the Mississippi, but the mud from the Mississippi and the Trinity and all the rivers between them is suspended in the water, and that's what makes the Galveston water so brown, is all this suspended mud. And that mud then is in the sediments, and you can see that because it doesn't fall apart. And I can feel it, and it's more fine-grained than the sand in the dunes. And if you look at it, you can also see the mud particles. Crab has also, if we look down in his hole, down in there, you can see some of the roots from a former coppice mound. This is probably a place, because of the human traffic, that the plants got trod down and not preserved, so that it doesn't preserve the coppice mound, but we do see the roots down in the crab's hole. Okay, I was talking about the profile of the modern beach, but let's take a little step back in history. We have this barrier island and we have the coast, and as you know, climate is changing. We had a period of about 10,000 years ago when we had an ice age. And at that point, almost all the world's water and a lot of the oceans, all the water in the ocean was trapped in the ice in the continents. And so the sea level was much lower. In fact, you can go out about 39 miles, and that's where the beach would have been 10,000 years ago. And people who are, you can't see them today because it's very hazy. On a clear day, you can see that there are oil rigs out there. And when they drill the oil rigs, they sometimes find pieces of mammoth bone, saber-toothed tigers, and all these animals that were around at the time of the Ice Age. Question is, we are having global climate change. What will happen to this barrier island through time? Man is trying to preserve it. They're adding sand in various places, but whether or not the island stays as sea level goes up, we'll just have to wait and see how that experiment plays out.